Okay, we will start with our discussion. We will continue with our discussion on kinematics of rotational motion as well as the dynamics of rotational motion. So, last time we had the discussion. So, now we will have sample problems. Okay, so shall we start by answering this problem? So we have an airplane propeller rotating at 1,900 revolutions per minute. So let us compute the propeller's angular velocity in radians per second and how long in seconds does it take for the propeller to turn through 35 degrees. All right. So here we are given with the angular velocity, but it is in revolutions per minute. Okay, so brief review lang class. Let's have a brief review of the concepts that we have learned so far. Okay, so we have learned about the angular velocity, which is equal to um this is the angular displacement rather. Okay, so this is the angular displacement and it is equal to the ratio of S and R. Okay, so S here is the arc length and then R is the distance from the center towards the point that we are considering. Okay, so this is the angular displacement theta. And then we also learned of the angular velocity, which is just equal to the change in the angular displacement with respect to time. And then we have the angular acceleration, which is equal to the change in omega with respect to time. So every time there is an increase or a decrease in the angular velocity, that constitutes or that would mean that your object or your rigid body is accelerating. Nasa angular acceleration. Okay. But if your angular velocity is constant, then zero po ang acceleration. All right. And then we have this relationship v. So the linear velocity or the tangential velocity is equal to r omega. And then we have also learned that the tangential acceleration, sorry, this is A. The tangential acceleration is equal to r alpha. And then we have the centripetal acceleration, A sub c, which is equal to v squared over r. So kaya omega squared r. Okay, so this are the equations that we have learned so far. And then we also have the kinematics equations class. We have equation number 1. You have omega is equal to omega naught plus alpha times time. And then you have theta is equal to theta naught plus omega naught t plus 1/2 alpha t squared. And then you have theta is equal to theta naught plus 1/2 sakto ba ni? Omega plus omega naught times time. And then lastly, so ganito equation, last equation. So you have omega squared is equal to, sorry, is equal to omega naught squared plus 2 alpha, you have theta minus theta naught. Okay, so these are the equations. These are the kinematics equations for rotational motion. Okay, so let us use these equations to solve for the following problem. So starting with this one. Okay, again, here we are given with the angular velocity omega, pero ang gihatag kay in revolutions per minute. Revolutions per minute. Now, you have to take note that one revolution, ang isa katuyukan, that is equivalent to 360 degrees. And 360 degrees is equal to 2 pi radians. Okay? So, ang isa ka revolution, one whole circle, that is equivalent to 360 degrees, and that is equivalent to 2 pi in radians. Okay? So, let us then convert this in radians per second. So, converting 1,900 revolutions per minute to radians per second. So, for letter A, we just have to convert 1,900 revolutions per minute to radians per second. Okay. So, we just have to write this one and then multiply it with the conversion factors. So, another conversion factor that we will be using is that in 1 minute, there are 60 seconds. Okay? So, to cancel out minute, we will put it in the numerator and then 60 seconds in the denominator. So, mag-cancel out na ning minute. And then here, you have 1 revolution is equal to 2 pi radians. Okay? So, this will cancel out also. So, all we have to do is to evaluate. So, 1,900 times 1 times 2 pi divided by 60. Okay, so you have to help me with this one because I do not have access to calculator as of the moment. Pila man ni siya class? Do you have your calculators with you? 1,900 times 2 times pi equals divided by 60. So it's 199, almost 199, approximately 199 radians per second. Okay, so you have here 199 radians per second. So 1,900 revolutions per minute is actually equal to 199 radians per second. So this is the angular velocity in radians per second. Now the next one is to compute the time in seconds does it take for the propeller to turn through 35 degrees. Okay, so for this, we need to convert first 35 degrees to radians because ang ato nakuha nga omega is in radians per second. So we will convert 35 degrees to radians. Okay, so for letter B, convert 35 degrees to radians to radians. So we have here, this is equal to 35 degrees multiplied by, ang atong gamiton nga conversion factor class is kadtong this one, 180 degrees times is equal to pi. Or pwede hapon 2 pi over 360 degrees. So, you can use this conversion factor. 35 degrees multiplied by this conversion factor. So, 180 degrees is equal to pi radians. So, you will get 35 over 180 pi. 35 divided by 180 multiplied by pi. So it's 0.611. Okay. So 0.611. Are you guys following? So 0.611 radian. So this is the equivalent angular velocity for 35 degrees. Okay, and then we want to know the time. So, ang atong nahibalaan lang, class, is the angular velocity, which is equal to 199 radians per second, as well as the theta. Okay, so you have this equation. Omega is equal to the change in theta with respect to time. Okay, so we are to find the time, delta t, is equal to delta theta divided by omega. Now, we are given with delta theta, the change in the angular velocity. So, na-turn daw siya into 35 degrees, meaning to say, man siya ang change in the angular displacement. So, you have 0.611 radians divided by omega, which is 199 radians per second. Okay? So the time it took for the propeller to turn about 35 degrees is equal to ilan ni siya, class? 0. Mga around 0.003 seconds. So as you can see, since dako kaayo ang angular velocity sa propeller sa airplane, so it will take it a very small time to turn 35 degrees, no? 0.003 seconds lang, maka-turn na siya 35 degrees. Okay? Tungod kay paspas siya og angular velocity. Any questions? Okay, so no questions. Let's proceed to the next problem. Okay. Yes? Ay mga questions in the chat box. Yes, Brian.
Ay ma'am, ano ganing kan di 180 degrees sa ang 1 di times sa 35 degrees.
Okay.
I-divide.
So it's a conversion factor. Here. Let's look for it in the slide. This one. So you can use any of these conversion factors. Okay, so you can use 360 degrees equals 2 pi radians. Or you can also use 1 radian equals 57.3 degrees. Or kini siya 180 degrees equals pi radian. Di ba? Nakay Cartesian plane. So kini siya 90 degrees. This is pi over 2, 1/2 of pi. This is another 1/2 of pi. Kini siya diri kay 1/2 gapon ni siya sa pi. 1/2 of pi. So 90 degrees ni siya. Kini po diri 90 degrees, right? Kini diri if we measure that 90 degrees. So as you can see, ang 180 degrees daay class is duha ka pi over 2 that is equivalent to pi. So pi over 2 plus pi over 2 that is pila na siya class? Pi over 2 plus pi over 2 is pi. And then, ang 360 degrees also is equivalent to upat ka pi over 2. So, kung naakay upat ka pi over 2, 4 times pi over 2, that is equivalent to 2 pi. So, pariharan ni sila. Kung gamito ni mo 180 degrees equals pi radians as conversion factor, you will get the same answer if you will use 360 degrees equals 2 pi rad. Okay? So, here is the equation also. So, katong kaganina, convert na to siya to radians. So, you have pi over 180 degrees multiplied by 35 degrees. Okay?
Thank you, ma'am.
Okay, so let's proceed. Any other questions? All right. So, for the next problem, we have a bicycle wheel with an initial angular velocity of 1.5 radians per second. If its angular acceleration is constant and equal to 0.3 radians per second squared, what is its angular velocity at t equals 2.5 seconds? And then through what angle has the wheel turned between t equals 0 and t equals 2.5 seconds? Okay, so let us list down the given first. So the given, we have the initial angular velocity, so that is omega naught, which is equal to 1.5 radians per second. And then we are also given with the angular acceleration, which is 0.3 radians per second squared. And then we are given with the time t equal to 2.5 seconds. Okay, so what is asked is its angular velocity at this time. So, itong mga pangitaon class is omega naught. Okay? It's omega, the final velocity. So, to find omega, we will use equation number 1 from the kinematics equations because we are given with omega naught, alpha, and t. So, we have use this equation. So, na kay omega equals omega naught plus alpha times time. Okay, so this is equation number 1 of the kinematics equations for rotational motion. All right, and then we just have to substitute. So you have 1.5 radians per second plus alpha, which is 0.3 radians per second squared multiplied by the time, which is equal to 2.5 seconds. Okay, so pila man ni siya class? One 1.5 plus 0.3 times 2.5, that is 2 point, pila ni class? 1.5, medyo langan kay watay calculator. Daghan pa ta natang ma-solve ng problem plus times 0.3. It's 2.25. Okay, so it's 2.25 radians per second. So, you have here an increase in the angular velocity from 1.5 radians per second to 2.25 radians per second, which is expected because your angular acceleration is positive. So remember that if the angular acceleration is positive, that means your omega is increasing. Okay? So for letter B, through what angle has the wheel turned between t equals 0 and t equals 2.5 seconds? So here, atong nakuha ang iyang final omega, no? Final angular velocity after 2.5 seconds. So karon ato na pong kuhaon iyang angular displacement. So unsa daw ang natuyok nga angle after 2.5 seconds ani nga wheel. Okay, so for this, sa nga equation atong gamiton. So we have several equations for theta. So we can use the second equation. Pwede guro to na to gamiton tong second equation, solution. So we have theta equals theta naught plus omega naught times time plus 1/2 alpha t squared. Okay, so you can use this, or you can also use the third equation, which is a little bit a little less complicated compared to this one. Okay, mag-square pa ta ani. Another equation is theta equals theta naught plus 1/2 of omega plus omega naught times time. Okay, so you can use this one. Let's try this two solutions or two equations and see if we will arrive at the same answer. Theta naught plus 1/2 omega plus omega naught multiplied by time. Okay. Ang gipangita class kay ang change in theta. Si theta final minus theta initial. Okay, so muna siya ang gipangita, delta theta. 1/2 omega plus omega naught times time. So basically, gibalhin lang na ko ning theta naught dire sa left-hand side of the equation, making it negative. Okay, so delta theta, this is what we're looking for. So you have omega is 2.25 rad per second. Omega naught is 1.5 rad per second. And then the time is 2.5 seconds. Okay, kindly help me solve this one. So you have 3.75. Ganino, nasa parenthesis, this is 3.75 times 2.5 times 0.5. So you have 3.75 times 1/2 times 2.5. 4.8675. Did you get the same?
Yes, ma'am.
4.6875. The unit is radians. Okay. Now, for the second equation, let's try the other equation, or you have theta equals theta naught plus omega naught times time plus 1/2 alpha t squared. So you have theta minus theta naught, balhin ako ni siya sa pikas gihapon, equals omega naught t plus 1/2 this is alpha t squared. Okay, so let's substitute. Delta theta equals omega naught is 1.5 times the time, which is 2.5 plus 1/2 0.3. This is your alpha. And then t squared, 2.5 squared. Okay. So kindly calculate. Hopefully, parehas lang answer. So different equations will arrive at the same answer. Pareha ra ba, class?
Yes, ma'am, parihara.
Okay. So let us continue with the next problem. Okay, so we have a flywheel. It requires 4 seconds to rotate through 162 radians. Its angular velocity at the end of this time is 108 radians per second. So find the angular velocity at the beginning of the 4-second interval and the constant angular acceleration. Okay, so let us identify first kung unsa ning mga given. So this one is, of course, the time, t equals 4 seconds. And then this one, 162 radians, muna siya ang angular velocity. Angular displacement, 162 radians. Now, we are given also with the angular velocity at the end of this time. So, that would be your omega, the final velocity, angular velocity. So, you have 108 radians per second. So, ang gipangita class for number 1, for letter A, is the initial angular velocity. So, what is the initial angular velocity? Now that we have this given, so unsa nga equation atong gamiton, class? What equation shall we use to find omega naught? So we cannot use the first equation because it requires us to have an angular acceleration pero wala man tay angular acceleration. So the only equation sa kinematics equation nga walay angular acceleration alpha is the third equation. So using equation number 3, using theta equals theta naught plus 1/2 of omega plus omega naught times time. So this is the third equation. So we will use this, noting that ang gihatag class is, can you know, see 162 radians. We will need to isolate omega naught. Okay, so dapat na to ma-isolate si omega naught, but these are just numbers. For example, theta is 162 radians. Theta naught is 0. Okay, equals 1/2 multiplied by omega is 108 radians per second. So na kay 108 plus ang variable nato kay omega naught. Wata kabalo sa value ani. Multiplied by the time, which is 4 seconds. Okay, so what we will do is we need to isolate omega naught. Okay, so let's isolate omega naught. Hinahinayon lang na to, class, para dito mga buyo. Okay, so you have 1/2 times 108. Pila man na siya? 54. Sakto? 54 times 4. Or pwede gihapon nga 4 times 1/2 para ma-simplify na nato, class. That is 2. No? Kato nga sa 4 kay 2. Multiplied by 108, so you have 216. So you have 216. I-multiply lang ni siya na ako, class, ha? I-multiply siya na ako diri. Tapos, i-multiply na po na to siya og 4. Okay? Plus, kini po siya, i-distribute mo ni siya na to. I-multiply po ni siya na to here. Okay? So, the same with this one. I-multiply siya na to sa 108. Multiply po siya na to diri as omega naught. Okay? So, you have 1/2 times omega naught times 4. So, you have 2 omega naught. So, you have this equation. Hapit na to ma-isolate si omega naught. So, 162 minus 216. Are you guys following?
Yes, ma'am.
Okay, so you have
Yes, ma'am.
162 minus 216. Okay? Gibalhin ako sa pikas nga side si 216, it became negative. And then, what is left here in the right-hand side of our equation is 2 omega naught. Alright? So, hapit na gyud na to ma-isolate si omega naught in the next page. So, you have 108 minus 216. Pila mo na siya, class? Faster. Charot. So, you have negative 108. Sakto? No? Kay marag ang, ay, 162 nini. 162 minus 216. How much is that? Negative ang atong makuha ni.
46, ma'am.
Negative
46?
54, ma'am. Negative 54.
Okay, so negative 54. Murag negative 54 go, dapat 4 ang tumoy, dili 6. Kindly check lang ha, katong nag-answer o pila to yung answer nga 6 ang last. So, negative 54. Okay? Equals 2 omega naught. Therefore, your omega naught is equal to negative 54 divided by 2. So, you have omega naught is 27, negative 27.
Yes,
Yes,
ma'am.
Is this correct? Negative 27. Sure na, class?
Yes, ma'am.
Yes. Okay. So, sakto ba na ito ang ano? 4 times 1 half. 2. 108 times 2 is 216. Sakto, no? 108 times 2 is 216. Wala to na sa iyo pa ni 4 times 1 half omega naught. So you have 162 in the other side. Tapos minusan na to og 216. So you have negative 54. 54, okay. And then divided by 2, so you have 27. Alright. So, feeling na ko, mali na itong answer na maghapon sa 1A. Okay. So, this is your omega naught, negative 27. Alright. Now, the next one is to find the constant angular acceleration. Okay. So, next is to find the constant angular acceleration. So, in order to do that, we will use equation 1. So, you have using equation 1 from our kinematics equation, we have omega equals omega naught plus alpha times time. So, since nakuha naman na to si omega naught, then we can use this equation to find alpha. Okay, so you have, manipulate lang yapon na to ang equation. Omega minus omega naught equals alpha times time. So, alpha di ay is equal to omega minus omega naught all over t. Okay? So, substitute lang na yun na to. Alpha equals omega. Omega is 108 radians per second. And then minus negative 27. So, take note of this. Minus negative 27 kay negative atong omega naught plus. Divided by the time t, which is 4 seconds. Okay, therefore, you have alpha is equal to 135 radians per second. Is this correct? So, ma-add man ni siya, class, kay negative times negative is positive. So, you will have 108 plus 27. Okay? So, 135 radians per second divided by 4. So, you will get
33.75, ma'am.
Okay, so 33,
Yes, ma'am. 33.75.
75 radians per second squared. Okay, so you have that one. So So, ingani lang no, this is how rotational kinematics work. Now, let's proceed to rotational dynamics para na po tayo examples sa rotational dynamics. So, I will be sending you this slide for your reference. Lah. Okay. And then, for rotational dynamics, you have this one. Let me share another slide. Na-discuss naman ni siya nato pod class, no? Na-discuss man nato tanan ang lecture nga part ani. Or okay, so we have the first problem. This one you will be using in order to get A cross B, you will be using, this is just review. This is just a review of the cross product. So A cross B, you will use the basket method to solve for this. Okay, so let's start with number 2. So an 18 kilogram child sits 1.5 from the pivot point of a weightless seesaw. How far away on the opposite side should his 40 kilogram mom sit if she is to balance him? Okay, so this should be our last activity sa laboratory class. Balance. Okay, so we are given with the mass of the child, which is 18 kilograms, and then daw siya sa 1.5 from the pivot point. And then, ang iya pong mama is 40 kilograms. So, aha daw mulingkod ang mama sa opposite end in order to balance the child. Okay. So, you have this. Try to draw a seesaw. It's not a good seesaw. So, from the pivot point, so sa seesaw class naman gyud sa tunga-tunga ng iya ang murag center of gravity. Okay, so naadiri ang child, which is 1.5 meters. 1.5 meters. Gikan diri sa center. Okay? So, 1.5 meters. Now, aha, mulingkod ang iya ang mama. Okay? Para mabalance siya. Okay? So, ito pangitaon is this. Okay, so in order for equilibrium to be attained, you need to satisfy these equations. So the first equation is the summation of forces should be equal to 0. And then the summation of torque should also be equal to 0. Okay, so now let us focus on this. Okay, so we have two torques here. So torque is just a twisting and a turning effect, okay, due to a force. All right. Now, let us calculate first the gravitational force of the child. So we call it F1. So it is equal to 18 kilograms multiplied by 9.8 meters per second squared. So this is equal to, ilan man siya class? 170, pila class? 178. 176.4. Okay, so 176.4 newtons. Okay, so this is the force that is due to the weight of the child. And then for the mother, we call it F2. So you have 40 kilograms daw si mother multiplied by 9.8 meters per second squared. So this is equal to 300, pila class?
392, ma'am.
92, exactly?
Yes, ma'am.
Okay, so it's 392 newtons. Now, according to this equation, the summation of torque, for them to balance, the summation of torque should be equal to 0. So what are the torques here? So nakay torque due to the child plus the torque due to 0. Now, by convention class, ang sa ganito, basta counterclockwise, positive, clockwise, negative. So, both of this, kini sila kay paubos ang ilaang force no nga gina-exert. Okay? The force that they are exerting is towards downward ang direction. So, this forces causes, or kini siya class, this will cause a counterclockwise nga motion sa imo ang siso. Kini po siya nga part diri sa pikas. Okay, sa mother, paubos. So that is clockwise. Kung kita ang maglantaw, no, clockwise ni siya padulong due to the weight of the mother, padulong sa ubos, pareha sa clock o dagan. Okay, where is it now? Pwede ta maglibog nganong na negative, positive. So, clockwise ni siya. Direport na po siya motion nga counterclockwise. Therefore, this torque here is positive. This torque here is negative. So, you have let me erase this one because T2 is negative man di ay. Okay? So, T1 minus T2 is equal to 0. So, the same ra gihapon ni siya kas parabit atong concept sa dynamics nga. For example, kung naakay force nga naa diri, so this is positive. For example, tension. Tapos kung naakay frictional force diri so negative siya. So, pagsulat ni mo ani, summation of forces along the x equals tension which is positive minus the frictional force equal to 0. Okay? So, gani. So, the same with this one. You have a clockwise nga direction, negative na siya. Clockwise direction, positive. Okay, na sabtan na class.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, now let us focus on this one. So, from here, you can see that si T1 di is just equal to T2. Torque 1 is equal to torque 2. So, transferring this to the right-hand side of the equation, so may mo siyang positive T2. Okay. Now, the force is going downwards. Ang imo ang lever arm kay perpendicular sa iya. Okay. So, you have unsay pangalan ani? 90 degrees nga angle for your force and displacement. So, basta 90 degree gani ang angle, sine 90 degrees is equal to 1. Therefore, katong imong torque, note, torque is equal to R cross F equals RF sine theta. So, this is just equal to ang imong torque when theta is equal to 90 degrees, then your torque is just equal to, masimplify lang siya to RF. Okay? Mawala na ning sine theta kay 1 naman siya. If if your theta is equal to 90 degrees, kung perpendicular ang force vector o ang katong R. Which in our case, perpendicular gid siya. Okay? So, R cross F na kay R1, F1 equals R2, F2. Now, ang pangitaon na to class is si R2 kung asa ang location sa mother gikan sa pivot point. Okay? So, R2 is just equal to R1 multiplied by F1 divided by F2. Okay? So, R2 is equal to, what is R1? It's 1.5 meter multiplied by force 1, which is 176.4 newtons divided by 392 newtons. Okay, so what is R2?
0.675, ma'am.
0.75? Okay.
675, 0.675.
Okay, so R sub 2 is equal to 0.75?
675, ma'am.
Ay, 675. Okay, so it's 0.675 meters. Okay, so as you can see, para mabalance sila class, dapat mas duol-duol siya sa pivot point, ang mas bugat, compared sa kining mas gaan. Okay? So the distance from the center towards the mother should be 0.675 meters. Mga less than half sa location sa iyang anak. Alright? So how about this one? Calculate F1 and F2 for the beam shown in the figure. Assume it is uniform and has a mass of 250 kilograms. Okay, so we have here calculate F1 and F2 for the beam shown in the figure. Assume it is uniform and has a mass of 250 kilograms. So this one has a mass of 250 kilograms. And then we want to know forces F1 and F2. Okay, so how do we do this? So as you can see, this beam is supported. So na siya support class. So this beam is supported Okay, so it is supported at both ends. Now, it is uniform. So this means that its center of gravity must be at the center. Sa iyang tunga-tunga. Okay, so let me show you the solution here, class.
Get sulit quality items with Laz Beauty. Shop for trending bestsellers. Get up to 80%.
Welcome to my channel. I'm Zhang Xu. Let's look at the problem 15 in chapter 12. In this chapter, we talk about the step.
Okay, we have this one. It's a 1 minute video lang. have
static balanced. In
can you hear it?
order to make the system balanced, we must satisfy
Yes,
two
ma'am.
requirements. Net force is zero, net torque is zero. Now we look at these systems. We need to make sure it is balanced, so net torque is zero, and so net torque is zero, so we look at this picture. So we consider this is the rotation axis, right? So the torque for it, first one FB, so FB times the distance from the rotation axis, x1 plus x2 plus x3 plus x4. Now we look at the F1, it is pointing down, so negative sign, because it's torque at opposite direction. So this is F1 times x1, and then F2 is x1 plus x2, and then F3 is times x1 plus x2 plus x3. Now we look at this one, gravity. The gravity is just x5, right? x5. Then we solve those equations, get the function for FB, input the known quantities, get the final answer there. The next one, we need to find FA and FB. FB is get can find FA, sure. Consider the net force is zero. So all the force up plus minus all the force down, these functions. Then you can get the function for FA and get final answer there. Thank you.
Okay.
And welcome back to the Turd Ferd Network. All right, so
Welcome to my channel.
Okay, so you have this one. Gisum up lang niya ang tanang torques. Okay, so you have summation of torque is equal to FB. So many FB. This one, the force that is kini siya going up. And then you have giad lang niya ang x1, x2, x3, x4. So this is the length of the whole the length of the whole beam. Okay? So basically this is numbers lang ni siya, class. So you have 2 meters plus 4 meters plus 3 meters. So, ana pag yun ay 1 meter diri ah. So, this is 2, 4, 3, 7, 8, 9, 10. So, 7, 10. So, FB times 10 minus F1, X1 minus, so as you can see, it is positive because it will cause a counterclockwise torque. Okay, so si FB kay padulong siya padulong siya paana pasaka. So it will cause a counterclockwise torque. It is positive, while F1 it is F1 should be it is negative po si F2. Negative po ang torque due to this. Negative po ning torque due to this one. Negative po ni due to this. Okay? I think it is in the sender. MGX5. So some that is placed, so it will cause a kanang force that is equal to mg, and then ang iyang direction gikan diri is x sub 5. Okay, now class, for this ang iyang pivot point kay kini Okay, so this is the pivot point for this example. Wala niya giingon, but based on the solution, ang iyang pivot point is this one. Kaya diri man niya gi-measure tanan gikan. Okay? So diri niya gi-measure tanan gikan. Alright, so substituting. So gi-substitute lang substituting all that is given, so we can get f sub b. Okay, so f sub b is equal to this one, f1 x1 plus f2 x1 plus x2 plus f3 x1 plus x sub 2 plus x sub 3 plus mg x sub 5 divided by x1 plus x2. Ngano gayon ni siya, class? This is, gikuan ni siya, gi-equate ni siya na to 0. Okay, so equating this to 0, sorry. And then, we will isolate f sub b. Okay, so nahimo ni siyang positive. Balhin siya na to sa right-hand side of the equation. This one also to the right-hand side of the equation, it became negative. Positive. Ma-positive po ni siya. And then, to isolate f sub b, you have to divide both sides of the equation by this para ma-cancel out siya. And then, diri akay, na akay denominator nga x sub 1 plus x sub 2 plus x sub 3 plus x sub 4. Okay, substituting everything, you will get this one. And then, to find f sub a, okay, so to find f sub a, class, we will use the other equilibrium condition also, which is the summation of forces is equal to 0. So, nakay FA positive plus FB nga positive, negative dayon ang uban nga forces, negative F1, negative F2, negative F3 minus mg, and then that is equal to 0. To find f sub a, just have to transpose everything to the right-hand side of the equation. Okay, so that is f sub a. Let me see if pareha ba na siya given sa toong problem here. Okay. So the difference here is that we are not given with mg. Okay, so let us try to calculate this. So again, we are asked to find f1 and f2. Okay, so let's start by having the summation of the torque. So you have summation of torque is equal to 0, wherein the torque kay, let me see. So F1 is positive. By the way, class, if this is our pivot point, kung naa diri si F1, wala ni siya torque, no? Wala ni siya torque. Yeah, because R here is equal to 0. So R cross F, bisan pag unsa kadako ang force imo ang ibutang kung naa siya sa pivot point or kung naa siya sa center of gravity sa imo ang object, then wala na siya torque. Dili na siya maka-cause og torque. Okay? So murag, for example, gani ka nang sa seesaw, kung naa mo sa tunga, kung naagid mo nagpatunong sa pivot point, you will not cause any twisting or turning effect. Okay, murag wala kay effect. So the same with this one, si F1 kay it will cause a 0 torque. Okay? So here you have positive F2, positive T2 di ay minus kani 400 times 2, 400, 4,000 newtons times 2 minus 2 meters ni siya class ha. Minus 2 meters. Kani dayon. 3,000 newtons multiplied by ang distance niya kay gikan diri sa pivot point kay 2 plus 4. So it's 6 meters minus kani dayon 2,000 newtons multiplied by ang distance, so 2, 4, plus 3, so you have 9. So 2,000 newtons multiplied by 9 meters. Okay? So, equating this, you have, equate ni siya na to 0, no? So, mahimong positive ni si T2, balhin ako ni sila sa pikas nga side, so mahimo sila tanang negative, positive. 4,000 times 2, that is 8,000. Plus 3,000 times 6, 6 times 3, 18. 18,000. Plus 2,000 times 9, 18 gyapon, no? Kabanikas. So, T2 equals, sorry, 18 plus 18, 36 plus 8, 36 plus 8, 44, class? Can you confirm, please? Okay, so 44,000 Newton meter. So, this is torque 2. Now, ang ipangita na to, class, is F2. Okay, so F2. F2 can be obtained so by this equation. So, na kay R multiplied by F2. Okay. So, si F2 di is equal to T2, the torque, divided by R. Alright, so the torque is 44,000 Newton meter divided by R, which is, pila ganitong R ni F2, na siya diri sa pinakadulo. So, 2 plus 4 plus 3 plus 1, that is 10 meters. Tako lagi kayo. So, you have 4,400. Sige daw, class. Newtons. 4,400 newtons. Wrong siya sa to ang given. 4,000, 3,000, 2,000. Ang iyang answer is 5,625 newtons. Why is that? Can you check this one, class? Correct. 4,000 times 2 is 8,000 plus 3,000 times 6. 6 times 3, 18. So, ba? 18,000. And then 2 times 9 is also 18,000. So, you have 36,000 plus 44,000 Newton meter. Okay, so I do not know where we assume it is uniform and has a mass of 250 kilograms. Okay. So we forgot, or we did not include the beam. Okay, so there should be a contribution for the beam which is equal to 200, ang iyang mass kay 250 kilograms. So due to the mass of the beam na ay downward force which is in the center, so iyang center of gravity, so na diri sa tunga-tunga niya, no, which is equal to the gravitational force mg. Okay, so let us add this one. So this will cause a negative torque also, sorry. So you will have another term here, which is equal to, pila ganitong mass, 250 kilograms multiplied by 9.8 meters per second squared, and then multiplied by multiplied by the distance. So, nasa sa tunga-tunga, that means 5 meters. Okay? So, can you include this one? So, mine plus, again, you have 250 times 9.8 times 5. Pila na siya, class? Ka-echo di. Okay. So, I get it. Di nyo makita ang ano. Lahi ang nakashare, sorry. sorry. Okay. So, you have this one. Okay, so we account for all the torques nga naadiri due to these forces. And then one additional is due to the mass of the beam. So dili siya massless. Pareha sa siso kaganina, massless man the weightless nga siso. So this is not massless. The mass is given, so it has contribution also for the torque. So we have 5 torques here, this one, and this, and also this one, due to the mass of the beam. Okay, so you have this summation of torque equals 0. You have T sub 2 positive. This is the torque due to force 2. Paana man siya, class. So counterclockwise, positive. And then all the rest will have a negative torque. So you have negative of 400 newtons times 2 meters minus 3,000 newtons times 6 meters minus 2,000 newtons times 9 meters. So asa ganin ni gikan ning mga 2, 6 ug 9. So diri siya gikan, class. Si force 400 newtons kay 2 meters siya gikan sa inyong pivot point. Mo ni siya ang pivot point. This is the pivot point. And then this is your 400 Newton force, 2 meters siya from the pivot point. Ang imong 3,000 Newton nga force, it is 2 plus 4 meters, that is 6 meters gikan sa pivot point. Ang imong 2,000 Newtons kay 9 meters siya gikan sa pivot point. Okay? And then, kini siya, this is another force due to the mass of the beam. This is equal to 250 kilograms times 9.8. Tapos, ang yung distance from the center is 5. Tunga-tunga. From the pivot point, naman siya sa center. So, 5 meters. So, you have here 4,000 times 2, 3,000 times 6, 2,000 times 9, and then kini 250 times 9.8 times 5. Okay? So, let's add another term here. Pila ni siya, class? Can you calculate 250 times 9.8 times 5? So that we'll be able to add it here.
12,250, ma'am.
12,250, ma'am.
Okay, thank you. So 12,250 newtons. Newton meter. So plus, kuan pa din ni siya, 12,250. So you have 56, sorry. 56,250 Newton meter ang torque. Okay? So this one. And then divide this to find F2. You need to use this equation. So your torque 2 is equal to this one, 56,250. Now to find F2, which is, mo man siya itong gipangita, no? Si F2. So i-divide lang na to si torque 2 og R. So 56,250. So this is 56,000. Dito mo siya may erase mo siya. We cannot erase it anymore. So ako lang siya i-crash out. 56,250 Newton meter divided by 10. So you have
5,625, ma'am.
Okay, so
5,625.
5,625 newtons. Okay, so that is your F2. Now, to find F1, summation of forces is equal to 0. Equilibrium man siya. So, what are the forces? You have F1, positive, negative, 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 positive. So, you have positive F1 plus positive F2 minus 400, 4,000 I minus 3,000 minus 2,000 newtons is equal to 0. Okay, now we know F2 now. So F2 is 5,625. So F1 is equal to positive 400, 4,000. Balhin na siya nako sa pikas nga side, making it positive. The same with this. Okay, and then this one, kini siya ang minus class, si F2. Minus F2, which is 5,625. So what is F1? F1 equals 432, 900, ilan na siya class? 9,000. Another one. We forgot to include katong gihapon nga term, kining 250 times 9.8. Sorry. So we have another term here. Katong sa beam, mass sa beam. Pila man ning 250 times 9.8 class? 2,400
Ma'am. 2,450, ma'am.
to 450.
Yes, ma'am.
Okay, so minus 5,625 plus 2,450 pa. Okay. Okay, mahimo man gyapon ni siyang positive if ibalhin siya nato sa pikas side of the equation. So this is equal to 0, ha? F1 plus F2 minus all the forces is equal to 0. So ibalhin siya nako sa pikas nga side of the equation so that we can isolate F1. So nangahimo silang positive except for F2 nga mahimo siyang negative. Okay? So you have 9,000 plus 2,450. So that is 11,450 minus 5,625. Pila na siya, class?
I-calculate ng kuan, ma'am, kanang F1 tanan.
Yes.
Kuan, ma'am, ang result kay 5,825.
5,825 newtons. Okay, so this is F1. Alright. So let us see kung correct ba tong answer. Yes, correct na tong answer. So F1 is 5,825 newtons and F2 is 5,625 newtons. Okay. This one is, I don't want to solve this one. But this is interesting. Okay. So for your assignment, class, for your assignment, kindly answer problem 8.8. Okay, so please answer problem 8.8. You can take a screenshot now, but you can also, kung mangyapon ni siyang ipasa, class. But you can take a screenshot now. Problem 8.8, you have to submit this 1/2 sheet of paper. All right. So let me see if we have still time. So we have 9:48 pila ka minutes left. That is
12, ma'am.
12 minutes left. All right. So let's spend the rest of the time sa schedule sa mga exams, class. So aside from rotational motion, we will have fluid mechanics pa. So next meeting, we will have discussions on fluid mechanics. Okay, so I was informed that naka-decide daw mo nga ugma ang exam sa momentum impulse and collision. So what time would that be?